Good morning, Jezebel. Here's your question. Yeah, you are the second person to email me about this. So, what I think I'm going to do for this problem is I'm going to record this and post it for everyone to see because I'm thinking many more people are probably going to have an issue with this. So, we'll turn this into a tutorial on how to do this problem because um, the first part of this problem I would think is something that you guys, if you've been following along, really shouldn't have any issues with. But it's the second part, I think, that is probably what's tripping people up. So here's what I'm going to do. I'm going to start with drawing this vector, right? So we have vector v. They want it written in linear combination form. They've given you the magnitude and they've given you the direction angle of 240 degrees. Now, 240 degrees is down here, right? That's one of those angles that we should remember from our time using the unit circle. Okay, so keep that in mind because when you look at what they want for the answer, they say simplify your answer using any radicals, use integers or fractions. They don't want decimals here. Now, we've talked about how you can express a vector in terms of its magnitude and its direction angle. So I've done a few videos that have included this, which I hope you've seen. Okay, this is a secondary way of writing a vector in component form. So when you look at this, right, with the magnitude and the direction angle in these places, I believe the previous video that I recorded from the classroom, we stopped here. And in reality, that's okay. All right. But we also said at one point that to write the to write the linear combination form of a vector, you needed to know its components, right? As numbers. When we take these two numbers, we take this one, we put it with an I, we take this one, we put it with a J. That's not going to work like this because this is not a number, right? This is a trig expression. So what we have to do is we have to get a numerical value for this and a numerical value for this. And then we can take those two numbers and we can put an I after one and a J after the other. Now, what that means is I can calculate this value, right? There's no variables here. The cosine of 240, you can plug that into your calculator, but you shouldn't need your calculator, okay, to tell me what the cosine of 240 degrees is. Think about the unit circle, and that's where this comes in, okay? The cosine of 240 degrees, and I will take this time again to remind you that I told you that you needed to know the unit circle backwards, forwards, upside down, and inside out because it was going to be a big part of this semester. It still is, okay? It's come back again here in chapter 6 talking about vectors. The cosine of 240 degrees is the x-coordinate on the unit circle of 240 degrees, which is negative 1/2. The sine of 240 degrees is the y-coordinate at 240 degrees, which is negative radical 3 over 2. So we have this. We still have the 40 here on the outside. These are the values of these two things. So now you're seeing where the fractions are coming in and where the radicals are coming in. Okay. Then all we have to do is take this 40 and distribute it into these two quantities. We did talk about scalar multiplication in our notes, where if you can multiply a number times the components of a vector. So when I do 40, and I'm going to do this the long way just so that there's no confusion after this. When I multiply an integer value, a non-fraction times a fraction, I multiply it times the top of that fraction. So this is 40 times negative 1 over 2. And this is 40 that's going to slide into the top here as well. So we have 40 radical 3 over 2, like so. After this, clearly 40 divided by 2 can be reduced. And I can also reduce here because this 40 is being multiplied times this radical 3. We've talked about this lots in class. If something's being added to something else, I can't cancel. I can't reduce a fraction. But if something's being multiplied by something else, I can. 40 can still be divided by 2 because it's being multiplied by radical 3. So we get 20 from this reduction here, and then we still have the radical 3 next to it like this. So these are the two components, okay, of this vector with in radical form rather than in decimal form. And then to express this the way that they want, we would just say negative 20 with that fat I at the end, minus 20 radical 3 with the bold J at the end. Okay, so here's the linear combination. And again, just to reiterate, the linear combination needs the components in order to be written. And in order to get the components, we had to do a little calculation with these trig values. Okay, so this answer would be good for this type of problem.